root functions, it's important that we begin with the parent function of the square root family, namely y equals the square root of x. A few things to note about this parent function is that it's always increasing. As we increase the values of x, we will get increasing values for y. As you take the square root of larger and larger numbers, you would expect those answers to go up as well. We are only looking at the positive square roots of each number, so the parent function is kept entirely within quadrant 1. We should not expect it to venture anywhere out. A positive number goes into the function and a positive number comes out of the function. Lastly, thinking about the domain, we know that we're going to have a domain of x is greater than or equal to 0 for the same reason. Creating a table just to get started, we have 3 points that are really simple to graph. The square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. You can find the square root of any input between those numbers, but those are just going to be the easiest ones to place on our graph. So we're going to start here with 0, then we're going to go to 1, then we're going to go to 4, 2. Clearly not linear. If we wanted to draw a curve, and we're going to, through these 3 points, we're going to need to be a little bit more creative about how we connect, quote unquote, connect the dots and get it to go through all of those points. Also knowing that the next one is going to be at 9, 3, which is roughly right over here, we're going to kind of shoot for that target as well as we draw. If you want to compare it to a graph that you've probably seen before, it is half of a parabola that has been turned on its side. So where normally a parabola is going to go up and down, we have turned this one on its side and we only want the positive part of it. It's from this graph that we are going to graph all of our transformations. Let's take a look at another one. This time, let's put in some transformations. We have the square root function y equals negative root x minus 2 plus 3. In your previous experiences, you know that this, changing the inside of the argument of the function, so changing the inside of the square root, this is going to move our graph right 2 units. The plus 3 at the end is going to move us up 3 units, and as always, when we change the sign in front of the function, this is where we're going to get a reflection over the x-axis. So we know that this graph, instead of starting at 0, 0, is going to start at the point 2, 3, right here. Now this one is a little bit trickier. Because you have the transformations on the function, it's a little bit harder to determine where that next point is going to be. We can have some anticipation of what we want to have happen. Maybe we want this to be really easy to evaluate. Well, if I make x equal 3, I can get a radical that's really easy to evaluate. And I know that I'm also now at the point 3, 2. So I'm going to kind of start going this way. That's also my reflection. I have a rough idea of the graph going like this, based on what I know about its shape. But the point that might be of particular interest to find is, what if I wanted to find the x-intercept? I know, because that function is now going to keep decreasing, I've reflected it over the x-axis, that at some point I'm going to cross the x-axis. At some point I'm going to keep going down till I can cross that axis, because I know that it's going to keep going forever. If I'm interested in finding that point, I can write myself an equation that just uses that any point on the x-axis has a y coordinate of 0. I solve this equation, I move the radical to the other side, and then I ask myself the very simple question, well, how can I get 3? Well, in order to get 3, I need a 9 in here. I need to take the square root of 9. Well, in order to get a 9 in there, I know that my x has to equal 11. A little bit of common sense goes a long way, so you're not messing around with trying to square both sides. Really thinking about, what is that number that I need? So way over here at 11, is where I would anticipate that graph would cross the axis. And that makes sense, right? I moved 2 spaces to the right, which shifted everything to the right. Maybe this 3 that I moved up has something to do with the square root of 9. There's some connections there to be made for sure. But worst case scenario is set the function equal to 0 and determine the intercept that way. Let's look at one more. Y equals 3 root x plus 4 minus 2. So again, this is going to be moving left 4 units. This is going to be going down 2 units. Left 4, down 2. So I know my new starting place is there. I haven't changed the direction left-right. So I'm going to anticipate that the action is going to happen this way. My new domain is going to be greater than or equal to -4. It's this number in the front that I now need to deal with. This number, because it's positive, just serves as a scaling factor, which means that this graph is still going to be increasing, but not increasing at the exact same rate as before. We would expect a much steeper hill at the beginning and then coming across. Another point of interest, now in the last example we looked at the x-intercept. What if I wanted to figure out the y-intercept? Well, I know that the y-intercept is always when x is equal to 0. Whoops, that should be a 4. I jumped ahead of myself. Root 4 is 2, 3 times 2 is 6, and that makes 4. So I know that my y-intercept is going to be at the point 0, 4. I know that I have to get through that point. If I just wanted to give a rough drawing, I know I'm moving in this direction. I know I'm going up because I did not reflect the graph. And I know I need to start here and get through 0, 4. So if I just wanted to give a rough sketch of it, it probably looks something like this. Is that a perfect drawing? Absolutely not. But if you just were interested in a rough idea of what the graph looks like, that's a pretty good contender. We have this other intercept here on the x-axis. You might want to try to find that one as well using the skill from the previous lesson, but I can tell you, or from the previous example, but I can tell you that one's not easy to find. So worst case scenario is you have a rough idea of what the graph is supposed to look like. You can easily determine the left, right, up, down transformations. And then for the scaling and reflection, pay attention to that direction, but also pay attention to this steepness factor. Did we make our growth much steeper than it should have been? Look how shallow this growth is at our first example versus when we're multiplied by 3. And we were able to determine that by finding that intercept. Those will be there, especially depending on how you move the graph. Those intercepts should be available to you to help support your graphing.